Now we can do a multiple choice math question that only 32% of the people got right when they took it on an official GRE test. First we'll do it the easy way, and then we'll do it the way that the official guide to the GMAT suggests that you do it. 8 points are equally spaced on a circle. If 4 of the 8 points are to be chosen at random, what is the probability that a quadrilateral having the 4 points chosen as vertices will be a square? Well, the first thing we notice is that 4 shows up in the problem, and 4 shows up in answer D. So we're probably going to be asked to do some math, so answer D doesn't look very likely. Since 4 doesn't seem very likely, 2 doesn't seem very likely either, so E doesn't seem like the right answer. Then we notice that 7 and 70 seem to have a relationship between them. But then we have to ask, why is answer B there, 1 over 35? Let's do the problem and discover why. Let's break down the problem into simple parts. First, we draw a circle. Then they want to know the probability that a quadrilateral will be a square. Then they tell us that 8 points are equally spaced on the circle. Now we look, if we take any one of those 8 points, we can make a square if we happen to hit on the other 3 corners of that square. So let's look. Let's pick one point. We have 7 points left, and 3 of them are part of our imaginary square, so we have 3 out of 7 chances of getting lucky. Now that if we land on one of those points, we have 6 points left and 2 points of our imaginary square, so we have 2 out of 6 chances of being lucky. If we're really lucky and we land on those, we have 5 points left, and 1 point is part of our magic square, so we have 1 out of 5 chances. Look, now we have a square. What were the odds? Well, we can cross out the 3 and the 2 on the top because we can divide it by the 6 on the bottom, and we realize that yes, there was 1 out of 35 chances of getting that square, and so answer B is our right answer. Now let's see how the official guide to the GRE suggests that we do the problem. First, it suggests that we find out the number of quadrilaterals you could make out of those 8 points, and then divide it by the number of squares that you could make out of those 8 points. To find out the number of quadrilaterals, we have to use the combinations formula, which means that since we have 8 points and we have 4 points that are possible, we do 8 factorial over 4 factorial multiplied by 8 minus 4 factorial. So that means on the top of our fraction we have 8 times 7 times 6 times 5 times 4 times 3 times 2. On the bottom of our fraction we have 4 times 3 times 2, and then 8 minus 4 gives us another 4 times 3 times 2. Now we can divide out. 4 times 3 times 2 show up on the bottom and the top. Then we can divide 3 times 2 on the bottom into the 6 on the top, and then we can divide the 4 into the 8 and make it 2. And so now we have 70 on the top. Doesn't answer A look very attractive? That's why they put it there. But don't forget, we have to figure out how many squares are possible, and it turns out there are 2 possible squares out of those 8 points. So we have to divide the 70 by 2, and there we get 1 out of 35. It's a longer way of doing it, but it does explain why the nerds wrote the answer grid the way they do, because according to their thought, 1 over 70 is the second last step, and so they try to give you predictable mistakes in the answer grid so that if you make them, you find those mistakes. We found it a simpler way. Testing for the public. Nonprofit since 1985, nobody makes things easier.